All right, first we start off by making a prim. To do that, you click Build, and then Build from the top menu, and then click Build. We build the prim, we name it. And you can adjust the preferences for your prim. Then what we want to do is we want to, with the prim selected, or if it's a object made out of multiple prims with that object selected, you click new script. And if you're adding a script to an object that has more than one prim, you add the script the same way, but in this case, the script goes in the root prim. You can put a script in a prim other than the root prim, but we'll leave that for another time. You want to right-click your script and click Properties. Here you can name your script. You can also set the properties of the script so others cannot see your code. I recommend testing your products with an alternate avatar, before selling them or making them publicly available. Have your alt try to copy and modify the object. I'm sorry. Can you not hear me? Are we having a problem? I can see audio. Can everyone hear me? Okay. All right. So, have your alt try to copy and modify the object and view the code, as well as test all the features of your product. Testing is very important. You want to be constantly testing your script while you are creating it. Test all the conditions that a user can do, including how your script handles incorrect input. So when the user of your product does something unexpected, you want your script to be able to handle that. That's just good programming. To open up the script, we double click it. And we want mono to be checked off, so don't mess with that. That's just for very old scripts. The only reason why that's there is some older scripts will have that unchecked, and they might not work with the newer mono. So we always want to keep that checked off when we're creating a script. Alrighty then, and as you can see, you're going to start off with default script there. And where's my, okay, here we go. Okay, so here we have, in red, we have the name of an internal command. This is a command that's built into Second Life and the other virtual worlds. And this just says a message. If you want the message to be displayed, to people that are nearby, you send it on channel 0. If it's not on channel 0, it's not going to be displayed. So this will say script running. This will say the message script running. Okay, so let's move on to the next thing. What is LSL? LSL stands for Linden Scripting Language. It was created for Second Life by the owner of Second Life, which is Linden Labs. It is used in many other online virtual worlds besides Second Life, including Social Mouse. Right. This is the website you can go to find out everything about scripting with LSL, Linden Scripting Language. If you lose that address, just do a search for LSL portal. The site gives all the information about all the little parts of LSL. Also, what I like to do is do an internet search for LSL space followed by what I want to find out about. For example, LSL space integer. And then I follow the link that says Second Life in the search engine. All right. So first thing you want to know when you're programming in any programming language is variables. In every programming language, you have variables and values. What is a variable? It holds information. In LSL, in LSL, there are a few different types. We have the integer. An integer just means a number that doesn't have a dot in it. So 837 is an integer, 12 is an integer, 36 is an integer, 12.4 is not an integer. And of course, there's limitations to this. In LSL, your integer can only be so big or so small. Here are some examples of integers. So to create to create a variable that holds an integer, we use the word integer in all lower cases. We put a space. We name the variable. You can give it pretty much any name you want. You want a name that describes what types of information it stores. You then
Call it Bob.
Yeah?
Never mind. Don't worry. Sorry.
So you then put an equal sign, and then you then put the integer, which is 12 or 38, or you can use a really huge number like the example that I gave. And with LSL, you have to end all your commands with a semicolon. Now, the normal number system that we're all used to is called decimal. But there is another number system that programmers also like to use called hexadecimal, or hex for short. Now, there has to be a way to distinguish the two, so you don't get the two confused. Why would we need an integer? Well, they're very important and useful in programming. So hexadecimal, it has a 0 and an X in front of the digits, the number digits. And that's how you know that that number is hexadecimal and not the regular normal decimal number system. So an integer is what's known as a data type. There are different data types. Different data types store different types of information. Another data type in most programming languages is a bool. This stores either true or false. LSL doesn't have bool. This data type doesn't exist in LSL. What LSL does instead is it assigns the word true in all capitals to the integer 1. And it assigns false in all capitals. Oh, I'm sorry. False in all capitals as the integer 0. Now, so in LSL, we have to use the integer data type for bools because there is no bool. It doesn't exist. We don't actually have to when we create a variable. So when we do, let's say if we do integer space and then we have a name of the variable, we don't have to give it a value right away. We can just put a semicolon after the end of it. We can give it a value right away, but we don't have to. Try to get back up here. Falling off. Okay, so let's see. Here we go. Okay, so here we got some other data types. We have float. Now, if you want a number that has a period in it, like 5.5, then you can use a float. Floats can also hold numbers like 87 and 16, but they have the added bonus of being able to have numbers that have a dot in them. If you want to hold some text, then we use string. So now, as you can see, we have we have 3 different variable names. We have a variable named b power on. Make sure to get the right upper and lowercase letters. So that's an easy mistake to make, is that your variable name is case sensitive. So we have 3 variable names. We have one called b power on. We have one called f temperature, which stores a temperature. And we have one called str, hello, msg, which stores some text. All right? You can change the contents of your variable later on as long as you use the right data type. So if you created the variable to store text, it's only going to be able to store text. It's never going to be able to store a number. It can store the text 1 in quotation marks, but you're not going to be able to store a number in it. So now to change the contents of your variable, you don't include the data type. So here we just do str hello message equals you're awesome in quotation marks, end it with a semicolon, of course. Now we've changed what str hello message stores. Str hello message doesn't store hello world anymore, it stores you're awesome. Right. Now we're going to look at comments. Comments start with the 2 forward slashes and end at the end of the line in LSL. So you can put a comment at the end, after the end of a command. So you see 2 comments here. We have 2 comments. In line 2, we created an integer called iYear, which can store a number. In this case, we're storing a year. Now we're going to get into functions. Now here, we're creating 2 functions. One function we're creating is called fnspeak. The other function we're creating is called fnadd. Now, fnspeak takes what's called an argument. The argument is what the function basically eats. It eats the argument. That's you can think of the function as eating an argument, eating arguments, and then spitting out something. So we're creating a function that fnspeak, and all fnspeak does is it takes text and it sends that text to our internal function, LLSay. So fnspeak works just like LLSay does, except for you don't have to specify the channel number. You don't have to put the 0 in there. You can't put the 0 in there. So, and then now we have another function called fnadd. What does this function do? It adds 2 numbers. And you see return, that's what the function spits out. So you can, fnspeak could use return too. What return does is return ends the function. So as soon as the function runs, as soon as return is run, the function is exited. And that information is spit out of that function. Okay, Hungarian notation. I like to use Hungarian notation most of the time. It is not required, but I find it helpful. It doesn't change how your program works at all or how fast it works. It's just an easy way to keep track of what your variables hold. So what you do is you name your variables starting with the lowercase I when they hold an integer. You name them starting with the lowercase f when they hold a float, which is a number with a dot, like 80.76. You name your variables starting with str when they hold a string, like hello world, and b when they hold a bool, which means it's going to be true or false. And of course, like I said, LSL doesn't really have a bool, so we're using integer for bools. And then the functions that we create ourselves, we start with fn. This is just a convenient way to better read your code, to make your code easier to read. You do not have to use this at all. It is absolutely not necessary. But I like to use it a lot of the times. So now we have our completed code here. Well, this is the rest of our code. And these are, so we see, okay, we have state entry and touch start. What the heck are those things? Those are called events. Events get triggered when something happens. State entry gets triggered when you change the contents of your prim. It also gets triggered in other situations. So when the contents of your prim get changed, the code on line 14 gets run. And what is this code to? It's the internal LSL function, which causes your prim to speak. Now we're using 0, which is the channel number, channel 0, which makes your prim speak on channel 0. And as I said before, if it's not spoken on channel 0, it's not displayed. So whenever the contents of your prim get changed, script running will then be spoken by the prim. Touch start gets run when the prim is clicked on. So here we have two codes. Line 19 and line 20. So on line 19, we're calling our FN speak function that we created earlier. And what does FN speak do? Okay, so go back a little bit real quick, in case you forgot. Okay. So when FN speak is called, FN speak then calls LLSay. LLSay then displays the text on channel 0. So what happens when we click on the prim? First, FN speak gets called with the argument hello world, which is a text string. Hello world, the text hello world that gets set to LLSay on channel 0, and the prim says hello world. The second thing that happens after you click this particular item is kind of complicated. We actually have on line 20, we're actually calling a function inside another function. So first what happens is FN add gets called. FN add adds 5 and 3 together. You see as FN add is eating 5 and 3. The technical term for this is FN add is being given the arguments 5 and 3. FN add then adds 5 plus 3, which equals 8. Now, FN speak can't speak a number. You can't say a number. Well, scripts can't say a number. They can't say a number. Not in LSL. So what has to happen is that number has to be converted to a string. A string is another word for text, as you remember. So the word string in parentheses converts the number 8 to the string 8. And the string 8 gets eaten, to use a non-technical term, by the function FN speak, which then says 8. So what happens when you click on this prim? Line 19, the prim says hello world. Line 20, the prim says 8. So the only thing that happens when you click on this prim is the prim says hello world, then the prim says 8. And every time you change the contents of this prim, the prim says script running. And that's your first introduction to LSL, Linden Scripting Language. That's just starting off. So now I'm going to open the floor to questions. I noticed somebody asked, why do we need an integer? Well, I'll answer that because when you have a script, you need to keep track of things. Depending on how advanced your script is, you need to keep track of things. And one of the things that you can keep track of is numbers. So this laptop that I'm using in here has to keep track of things. It needs this laptop that I'm using in front of me. It has to have a list of all the different slides, right? So it probably uses. I didn't actually look at the code, but it probably uses numbers to tell you to figure out, to know which slide it's on. So is it on slide number 1? Is it on slide number 2? Now, when I click the next button on this laptop, it's got to go to the next slide. How does it know to get to the next slide? Okay, well, the next slide is the number of the slide it's on plus 1. And when I click the back button, the previous slide is the number of the slide it's already on minus 1. So without numbers, integers, we wouldn't be able to keep track of that. Another thing you might be asking is, why do we even have integers when we have float? Well, integers, the integer variable can actually store much higher and lower numbers than a float can. So an integer variable can store really huge numbers and really small negative numbers, like negative 100,000 or a positive 100,000. The float variable, it can't store numbers that are that big and that small as the integer. So it gives you another option. And most languages will have integers in them. Any other questions? Everybody understand the material? Mostly, hopefully, mostly. You're okay. You're a little confused. Yeah, I'm sorry if I went a little too fast. What are you confused about? Social functions and the relationship to integers. Okay, well, sure. So let's go back to our functions here. All right. Let's see. takes a little bit to res. Okay. Functions don't have to work with integers. They can if you don't always have to use integers. It's one of the different tools that we have. We have integers, we have floats, we have text, and those. Now we have fn add. Okay, so fn add takes two floats, fa and fb. We could use integers for fn add. We didn't have to use floats for fn add. We could have used integers. So we could replace, see line 5? You can replace the word float with the word integer. And I encourage you to do that if you decide to play around with this if you decide to make this code yourself. I encourage you to replace all the word float with the word integer in line 5. And it will still work. Because the reason why it will still work is because here we use 5 and 3, which are both integer, which are actually integers. 5 and 3 are integers. So variables that hold float can also hold integers. Well, they don't really hold integers. They do and they don't. They hold a number that's considered an integer, but it stores it as a float. fn speak is not something that is a function that we made ourselves. LL say is a function that's built in. So fn speak and fn add are functions that we made ourselves. And like I said, fn add, you could make it work with integers instead of floats. If you make it work with integers instead of floats, you have the advantage of being able to add larger numbers. You can add larger numbers with better accuracy. But you won't be able to use numbers like 8.7 or 8.36. So either way works. Either way works. You can store the number. You can store an integer in a variable that's you can store an integer in a float variable. You cannot store a float in an integer variable. When you store, if you try to store the number 87 into a float variable, it turns into a float. It basically turns into like the number, like if you try to store 87 into a float variable, it'll basically store it as 87.0. So they're just, it's up to you what you want to use, whether you want to use an integer or whether you want to use a float. You decide, if it needs to work with numbers such as 98.6 or 80.75, then you have to use a float. If it doesn't need to work with numbers that have a point in them, then you can use integer and you'll be fine. All right? Hello World. Yeah, that's the Hello World is our classic computer program. Basically, there is a Hello World program for every language, every computer language that there is. There's probably a Hello World program for every single computer language out there. It's the typical starter program for every language. how do you make a program that says hello world is usually your introduction to every language, every computer language there is. All right. So does that clear things up? Does that answer your question? Social. Awesome, awesome, awesome. I'm glad to hear it. Any other questions? This is just scratching the surface. This is just getting your feet wet with programming. We're going to have some more classes in the future where we're going to be able to do some more things and have some more fun. And pretty soon, you'll be able to be making your own custom prims that can do all sorts of different things. There are, if you want to dig into the LSL portal on your free time, there's all sorts of different things you can do. You can change colors. You can make your prims change colors. You can make your prims change textures. You can make your prims change pictures on them. You can make them say things. You can make them interactive. You can make them listen to people. We're probably going to get into listening, letting your prims listen. And that's where channels besides channel 0 come in. Because if you get more advanced, when you get more advanced, you're going to be able to create prims that can listen to not just on channel 0, but other channels too. So people can literally type commands into the prim, and if they're not on channel 0, they're not going to be in the public chat. Only the people aren't going to be able to see those commands. That's why we have channels other than 0. Oh, with the scripts talking with another. Oh, we'll get to that. We'll get to that. That's another event called Listen, and that's kind of complicated because you have to tell your script what channel you want it to listen to, and then you have to have your script be able to interpret that text that it's listening to. The text that your script hears, the script's going to have to interpret. And depending on what commands you type into, what commands you talk, depending on what you say when you're talking to your prim, depends on how your prim's going to respond. But that all has to be programmed in. Your prim doesn't automatically know. Your prim doesn't automatically understand text. It has to be programmed to do that. So that's more advanced. So we'll get to that. We'll get to that. All right. So I think that's about it. So don't worry about prims listening. Yeah, we will get to that possibly next week. All right. Cool. I'm happy that you're happy. I got a lot of material to put together. Got a lot of material to put together for technique. Oh yes, absolutely, absolutely. That's why I wanted to open up to questions. But we're not gonna. I think we went over. I think we did. I'm so happy you did. I'm so happy you did. About an hour with the questions. So, that's it. Yeah, yeah. That's why I was planning on opening the floor to questions. Next time I can mention that right at the beginning. There will be a chance for questions after. I can always say that.
I do have another question. I'm on mic here now. Okay. I know the state entry is, I guess, that's when it first enters, like what it's going to do as soon as it reses in world, right?
No, that would be on res. That's actually a different event for resing in.
So, like on the one you have here, the script you have posted, the big one here yet, where it says default and state entry and then say. So that's like upon pulling it out of your inventory, that's what, is that resing in maybe? Oh, when we make the box? Is that when we make the box state entry? Trying to figure that part out.
Well, there are several things that can trigger state entry, but one of the main things that trigger it is when the contents of your prim changes.
Okay.
So when you update your script, it triggers state entry because the contents of your prim change. Your state entry will trigger. Resing the object won't trigger state entry though. All right? That's on res, on underscore res.
Okay, cool. Now the FN speak, I know you said that's one you created, but is that, and then I got to see the FN add. So is that like if it says hello world, then like what does that line 20 mean?
That's
like
line 20 means first it calls FN add, which adds two numbers. And then it changes that number to a string, and then it sends it to FN speak, which then speaks it. So the only thing line 20 does is it says 8. It makes the script say 8. So anybody that's near the prim will see the prim saying 8. It'll actually say 8 with a period and a bunch of zeros. So I actually have a
Okay, so if I change the 5 and 3 to, let's say, 10 and 2, then it would just add the numbers and say 12. So it's like a little calculator almost.
That's exactly what it is.
That's cool. Okay, I get it now. Oh, that's cool. And you said you invented the FN add, like that's not like a LL thing?
Correct.
A LSL thing? That's cool.
That's just an
That's cool.
of how to create a function.
That's cool. Now, how does it know to do the FN add? How does it know to add it?
It knows it because we programmed it to do it. going back here. Okay, we can see that FN add return FA plus FB.
Okay. Yes. See, I didn't see that. Well, I saw it, but I haven't. But I get it now. So it says float FN add. So float FA, float FB, return FA plus FB. That makes sense.
Mm-hmm. And if you did it with integers, then it wouldn't be able to do numbers like 8.7, 8.8, but
Okay. Okay, I'm starting to understand it pretty well now. Okay, everything's starting to make a little bit of sense. So you had to tell it up there to do, I guess, the end result, which was the 5 plus 3.
right.
Okay.
And you're telling it that the two things that it eats are floats, and the information that it spits out is a float. That's why float is there 3 times.
Okay. And you said it's better to use a float than an integer, right?
One is not better than the other. It depends on what you want to do. You have to decide. You have to make the decision. Do I want to use an integer? The advantage of an integer is that it can handle larger numbers without error, without as much error. The advantages of a float is you can do numbers like 8.37. So do you want to be able to handle numbers that are really large and really small without having a lot of error? Or do you want to be able to handle numbers that have 5.763 that have a point inside of them? You got to decide that. That's a case-by-case decision.
Okay. Now, would this calculator act the same if you added integer instead of float? It would kind of do the same thing?
Yes, but then you wouldn't be able to
Okay.
do numbers like 17.3 or 17.62. It would work exactly the same.
Okay. So almost can one say that we can use them interchangeably, except like you said, if you want to use a decimal or not, or a higher number or not?
Exactly.
Okay. No, it's good. I'm actually starting to understand, so this is good.
It gets stored differently. So you do have to keep in mind that a float internally gets stored a little differently than the way integer gets stored.
Okay.
So if you're comparing the two numbers together, let's say you want to make a script that compares two numbers together, you might run into a little bit of a problem if one's a float and one's an int.
Okay. Anyone else has any questions? I feel like I'm taking all the questions. Like I'm just, oh my God. No, it's good though. I want to learn. There's a lot of stuff I understand and some of it I don't. I think I'm okay. Yeah, I think I got everything, all the questions out I had.
Yep. And you got your note card there, and if you go to the bottom of your note card, you have like a little I just gave a picture of the script actually.
Thank you.
Yep, you got the code there. All right. Well, that about wraps it up.